Alright, we're looking at charts now. We've already discussed histograms, box plots, dot plots, and stem leaf plots. We're going to continue our discussion on that and look at bar and pie charts, line charts, and scatter plots as they look at different types of data. Bar and pie charts are really good for frequency tables, where you have a set of data and it's the summary or the frequency of each one. In this case, what type of colored shirts do a group of students have in a classroom? 4 students had red, 7 had green, 5 had blue, 10 have yellow. So we're going to highlight the data, insert, column, and we pick the top left hand, and there you go. We can change the color based on what any of these schemes, and the little arrow down here lets you choose some more variations. Change to green, black, purple. We're going to leave it at blue for the time being, and let's change the title. So, color of student shirts. And in this case, we don't really need the legend, so I'm going to go ahead and delete it. And we have a pretty good looking chart there. Nice thing about bar charts is it allows you to see comparatively in a nice linear fashion which one has the highest, even if they're not sorted by highest to lowest. Yellow is definitely the highest at 10. Blue is second round, but green is about 7. Blue, by looking at it, between 4 and 6 is 5, and then red is 4. So even if we didn't have the numbers right here, we can visually see it. Now that's important because when we look at this from a pie chart perspective, so I'm highlighting the data again and creating a pie chart. It's not so easy to tell how much of them is how much is which. We obviously see that yellow is the biggest, green is the next, but blue and red look pretty close together. It's very hard to distinguish which one. However, we can add data labels to it, and this will help immensely. 7, 10, 4, and 5. Now with pie charts, there is some controversy with them. There is a movement within the statistical community that says not to use them at all, mainly because it is so hard to visually see or analyze the data. In the case of the blue and green, it's very hard to distinguish which one's bigger and by how much. Whereas on the bar plot, it's very easy to say, well, yeah, blue is a little bit higher than red. Here, not as easy. I don't see a problem with pie charts as long as you understand that people have a hard time comparing the slices against each other. So if you're going to use a pie chart, you have to be careful about it. I like to use the rule of 5 fingers. If there's 5 slices or less, pie charts are pretty good. In addition to it, there has to be either a really big slice, in this example, the 10, or the purple region, or a very small slice. And that is where you want to focus the reader's attention to, is either that really big slice or that really small slice. If you're trying to compare the 4 and the 5, and that's your main point of the graph, pie charts are very, very poor at doing that. Okay? But if given the choice, I would use a bar chart every single time because of the simplicity. It's easily read and it's not difficult to understand and compare and contrast. Alright, so I'm going to go ahead and delete these so I can clear up some space here. The next chart is the line chart, and the line chart can be used with a bar chart. So we'll see what that looks like. So I'm just going to highlight the data. And again, nice column. You can see how it goes up and down, but it gets kind of messy, and especially if you have a large run of data, it gets really awkward and just hard to see. So instead, we're going to use a line chart, just right here. It's a lot smoother. We can see exactly what we're looking for and adjust accordingly. Line charts are best for like time series or when you have a long string of data. Line charts are not very good if you only have 4 or 5 data points, unless you're comparing a large number of them and you have too many bars in a bar plot. So comparing line charts versus bar charts, line charts are for long strings of data, particularly time series, stock data, annual reports, number of sales per week or month or day or whatever it may be. Bar charts are more for stationary snapshot type data, where you have a particular time frame that you're just looking at. The number of sales for a week for a particular person, that sort of thing. Okay, so that's a line chart. Now a scatter plot is like a line chart except that you have 2 variables. And what you're doing is you're comparing one variable versus another on the same graph. Now the trick with scatter plots and with all these plots is whatever your x-axis is, it has to be the first column. So date is on our x, or for the horizontal line, x is here, but it's most particularly important with the scatter plot. So I'm going to go with x and then my y1, insert scatter plot. And I'm just going to pick the random dots here. Okay. And as you can see, just a nice random dots throughout the process. This is particularly good as an introductory step to when we do regression analysis. We'll have our x variable down here, our y variable over here, and we'll see how they look. From there we can add things and so on and so forth. If you want to connect the dots, fairly simple. We'll put that there with the dots included. You can see a nice line of how it looks. Now another trick is, well, what if I want the x, but I want the y too? Well, you highlight your x, then you hit Control, and while holding down the Control key, highlight the data next to it. So it doesn't have to necessarily be side by side. Again, scatter, and let's put the ones with the line and the dots both. Again, or let's just look at it from a line perspective. Let's try that one. Okay. So there you have it. You'll also notice that there is the 3-dimensional choices for a lot of these. I wouldn't suggest using them, mainly because they're extremely difficult to read. Given this example, where is this point at? Looks somewhere between 10 and 15, but we're not entirely sure where that is. It's like it's the number 2, so it looks like 13. But it could be anywhere in between that. Is this 20? Well, yeah, but it looks just slightly under it. 3-dimensional plots make it very difficult to understand and analyze the data clearly and effectively. Same with data like this. It's very difficult to see where that is as compared to, say, just the simple, boring bar plot. There it is. We know exactly where it is. We know exactly what's going on. And even this, when you do the 3-dimensional plot, becomes very difficult to see exactly what's going on and compare and contrast each of those bars. So as a general rule, avoid 3-dimensional plots. While they look good, they do not portray information very well. And there's an ethical and moral problem with them as well, as you are hiding or misleading information through 3-dimensional graphs. So please avoid them at all cost. Go with, instead, as boring as they may be, just the regular plots just like this. It It conveys the information clearly, it tells the reader what's going on, and they are able to derive or see the information that they want to see. So that is an introductory to line charts, scatter plots, bar and pie charts, as well as the other charts that we've talked about. I hope to see you in the next series of videos where we talk about probability.